Okay, so in this video, we're gonna work on modeling still. We've got a different type of problem that we're gonna model here. It's time needed to do a job, okay? So in this situation, we've got a heavy rainstorm coming. The water level in a reservoir needs to be lowered by 1 foot to accommodate the water that's coming in via the rainstorm, okay? If we just open spillway A, all right, the water level would be lowered by that amount, 1 foot, in 4 hours, okay? If we just open spillway B, the job would get done in 6 hours, all right? But the rainstorm's coming and it's coming up on us quick, all right? So we need to open both spillways because we need to get the job done faster, all right? So what we need to figure out is how long will it take us to lower the water level by 1 foot if we open both spillways A and B, okay? Now, in all honesty, you're not gonna do many of these problems, okay? And it's probably not the best thing to say at the beginning of a video, but the process of setting up a model for situations like this is important. The ability to solve the type of equation that is created when you're doing a problem like this is important, okay? So this still serves, a couple of pretty large purposes. So even though you're not going to be working a lot of job problems going forward, the understanding of modeling and the understanding of solving the type of equation that results here is important, okay? So let's build our model first, all right? So in this case, we know that in 4 hours, spillway A gets the job done. So let's, a fraction of that, okay, done by A in 1 hour. So we've got the fraction done by A in 1 hour, okay? We're gonna add the fraction done by B in that same hour. So now they're working together. So A is gonna get a certain amount done in 1 hour. B is gonna get a certain amount done in 1 hour. And we want to add those two together, okay? Well, when we add those two together, we're going to get the fraction that's accomplished by both, okay? So this is our model, okay? So for spillway A, okay, the fraction done by A in 1 hour, well, if it takes spillway A 4 hours to lower the water level by 1 foot, then in 1 hour, it would accomplish a quarter of that, okay? So 1 out of 4. The fraction done by B, well, spillway B does the entire job in 6 hours. So in 1 hour, spillway B would accomplish 1/6 of the job, okay? If you want to, you can kind of think in terms of percentages, all right? In 1 hour, spillway A would do 25% of the job, okay? Because 1/4 is 0.25 or 25%. B, in that first hour, would accomplish about 16 2/3, or exactly 16 2/3 percent of the job, okay? Because 1/6 is 0.16, and then the 6 repeats forever. So it's 16 2/3%, okay? So in 1 hour, if you were to combine those two, if you were to add those two together, we would accomplish almost 42%, okay? 41 2/3% of the job would get done, okay? So the fraction done by both, well, I don't know how long it takes, so that's going to be 1/x, okay? So in 1 hour, we don't know what part of the job would be done by both just yet, okay? Even though I just estimated it for you using percentages, okay? So let's take these values and plug them into our model. So we got 1/4 plus 1/6 equals 1/x, all right? So I've got rational expressions here, or fractions, however you want to refer to those. So in order to eliminate fractions in the first step, I want to multiply each of the terms here by the least common denominator, okay? So the numeric part of the least common denominator, the least common multiple of 4 and 6 is 12, okay? And then I've got the variable expression here, x, to go along with that. So the least common denominator is going to be 12x, okay? So what I want to do is I want to multiply each of these terms from the equation by 12x, okay? And what that should do is eliminate all fractions, okay? If you've still got fractions after you did this step, then you didn't find the least common denominator, all right? You should eliminate fractions here. So 12x times 1/4 is going to be 3x. 12x times 1/6 is going to be 2x. And 12x times 1/x, well, those x's cancel out, and I'm just left with 12, okay? So this pretty ugly equation here, just by multiplying by the LCD, becomes a very simple linear equation. 3x plus 2x equals 12, all right? So we get 5x equals 12, we're going to divide by 5, and x equals 12 over 5 hours. Okay, well 12/5 as a fraction in hours doesn't really do us any good, so let's make that a decimal. That gives me 2.4 hours. Okay, so I know it's 2 hours and a little less than a half, so I could multiply this 0.4 times 60 minutes to get the exact amount of time here, and that would be 2 hours and 24 minutes. Okay, so if we open both spillways A and B, it's going to take 2 hours and 24 minutes to lower the water level in the reservoir by 1 foot. Okay, so that's time needed to do a job problem. How you set those up, it's the fractional part done by each object, in this case each spillway. Add those together, it equals the fractional part done when both are working together. Okay.